Okay. On Zoom, are you hearing us?
Yes, yes, everything is good here.
Perfect. So I start. My name is Hans-Werner Jacobi. I'm director adjoint at OSUG, who is kind of behind this new series, Les Grands Séminaires. We are Gonéri, who will talk the first time. And I have several notes here to tell you what this is. So the Grand Séminaire, those of you who are here at OSUG since many years know this. Maybe we had this kind of larger or bigger seminars some time ago, and this has now a new initiative to continue that, or start with that in a new form. And the idea is apparently to create some more interaction between all the unities, the institutes, the laboratories. Since the beginning of this year, OSUG now stretches from Thonon-les-Bains, via Chambéry, Grenoble, just until the Col de Lautaret. So this is a large area which is covered by the units, and we represent like 1,400 people in total in all these different institutes. So it's difficult to get these together, and the idea is to have this with the Grand Séminaire to create more interaction between within and between the community. Who will give these seminars? Scientists, engineers who can talk about a subject which is interesting many different groups in these different institutes. The participants, the expected participants are of course, also the scientists, the engineers, but also the postdocs, of course, the PhD students and other students who are in all these institutes. And today, I think we have around 100 people who join the seminar. The goal is, the aim is to have until somewhere between 3 and 6 seminars per year, organized in the different institutes. And this is, of course, then also in cooperation with the organizing teams in the different institutes who organize regular seminars. They agreed to don't do seminars in parallel to this. So this is also kind of organization OSUG has accomplished, so that there's this one big seminar occasion, so that everybody can participate. Again, this is in cooperation with the institutes who propose speakers for these larger topics, and it is financed, of course, no, not of course, it's financed at the end by the LABEX OSUG. Today we have the first one in this new series. The next one will be end of June, and the speaker there is Frédéric Lecheneau, who will be at ISTER, and he will talk about réseau des neurones au laboratoire, apprentissage, stratégie, contrôle. So that is something about machine learning, artificial intelligence. There we start with a seminar here at Dieu by Gonéri.
Hello, so I'm Gaël Durand, research scientist at IG, and I'm going to briefly introduce our speaker today. Gonéri de Cozannet is a research scientist at BRGM in Orléans with a specific expertise on the impact of sea level rise. And he has been lead author of the working group 2.6 assessment reports. So as you can see here, this report concerns impacts, adaptation, and vulnerability. And you are not here to listen to me, but to Gonéri. So Gonéri, thanks again for coming here today. And please, the floor is yours.
Thank you. Thank you, Gaël, for this invitation. Thank you very much for your invitation. I'm very happy to be here in Grenoble today and speak about this second assessment report. So what you see on the screen are 2 different coral colonies. On the left, you have healthy colonies. And on the right, you have colonies which have bleached, meaning that they have been affected by marine heat waves. And the algae have left the corals. And basically, it's becoming an increasingly problem, especially in the Indian Ocean and also in the Western Pacific. And especially since the 2016, we see more and more warming events that basically destroy these corals. And of course, it's a problem because corals host 25% of the marine ecosystem today. And also because they provide, for example, sediments to beaches, and this prevents erosion in small islands. So this is one of the major impacts of climate change, and this is one impact that we are increasingly seeing today. So I'm going to speak about this report of the second assessment. Okay, I have a small problem with I'm sorry. Okay, I see. Thank you. Merci. Thank you. So what is the sixth assessment report? So this is the most accurate and recent synthesis on climate science. So working group 1, I think you had the presentation by Gerhard Kriner previously. On climate change impact and adaptation. So this is working group 2, the report I contributed to. And on mitigation of climate change, this is a report that was published in April. This is about solutions to reduce future global warming. So this report informs governments about the consequences of their decision. So it is not policy prescriptive. You will find absolutely no recommendation in this report. However, they can provide information about to which extent governments are on the track to adapt to climate change, to reduce climate change impacts, and of course to mitigate climate change and ultimately to achieve the sustainable development goals like reducing poverty, having good education, and reducing impacts on ecosystems. So within working group 2, we are 270 authors from 67 countries. We analyzed more than 30,000 publications in 4 years, but we were supported by 700 contributing authors, and also by many many people who made comment to the report. So we have 60,000 comments during the whole process, and all the people who wrote the study actually. So I'm going to speak about this report. But first, I will remind a few key messages from the working group 1. And the first key message is actually that humans have caused the surface temperature increase of approximately 1.1 degrees since the pre-industrial era. And you can see that on the right figure. You can see that the observation in black represent approximately 1 degree of global warming with respect to the pre-industrial era. You can see that the model simulations that integrate this human forcing are able to represent the observed climate change, but that other simulations that don't integrate greenhouse gas emission increase, but integrate, for example, solar variability, volcanic impacts, etc., are not able to reproduce them. So this is a proof that climate change is due to increased greenhouse gas emissions. There is a small, the signal is partly masked by aerosol emissions too. And there is a strong conclusion in the report that 100% of the observed global warming is actually due to greenhouse gas emission. And even a bit more than that, if you consider that aerosol are actually masking a bit of this signal. So this climate warning is unprecedented since at least 2000 years. This is what you can see on the left. So I'm just going through a few key messages from this report. So there is a very message on climate extremes. And here you can see, you can recognize the world, and you can recognize that America and Eurasia here, for example, you can see that hot extremes have become more and more frequent and more intense in most regions since the 1950s. And this is virtually certain. And climate change is the main driver of this change. If you go regionally, there are some regions where this increase, you have high confidence in this statement. For example, in Western Europe, the first heat wave event that was formally attributed to climate change was the 2003 heat wave, which affected France. So I'm going through these messages because basically what you will see in the impact report will be a consequence of these statements. Actually. So the second statement is about climate extreme on precipitations. So as climate is warming, you see more climate rainfall extremes. And this is due to the fact that with 1 degree of global warming, you have 7% more water vapor in the atmosphere. And this water vapor well, it goes back as heavy rainfalls. And for example, in 2016, we had a heavy rainfall in France, which have the probability of occurrence is twice, the probability of occurrence is multiplied by 2 in a warmer climate. So you can see that the confidence is lower, but still we have we see that the human influence is likely the main driver of increased precipitations. And you see also that we have more evidence in Europe and Asia than in Africa. It's due to the lack of studies and lack of data in some regions. And finally, we see increased drought, especially in California and the Mediterranean. And this is due to the fact that the soil are getting drier quicker, and basically there is more evapotranspiration. So even without change in precipitation, you have an increase of drought in some regions, especially in these two regions, Mediterranean and California. Sea level rise, we have a very strong statement on sea level rise in these 6 assessment reports. We know that sea level rise will continue beyond 2100, that it may exceed 2 meters and reach up to 15 meters in 2300. But even before that, we cannot exclude a large Antarctica collapse leading to 1.5 meters in 2100. So all the consequences, all these aspects, all these drivers are really the key drivers of the impact, adaptation, and vulnerability conclusion in the second group. And the key message of this group is here. The scientific evidence is unequivocal. Climate change is a threat to human well-being and to the health of the planet. Any further delay in concerted global action will miss the brief, rapidly closing window to secure a livable future. And this report offers solutions to the world. So when I had this slide on the table, I had difficulties to translate it in French and support, because of course, you see the strength of these words. A rapidly closing window to secure a livable future. So it's really strong words. It's not prescriptive again. It's just making the point that without rapid action to adapt to climate change, to reduce climate change, we will be unable to achieve the sustainable development goals that have been agreed by different states in the United Nations, and to reduce poverty, to secure food production before 2030. And within the group, working group 2, we are not only working with the driver, so for example, more heat waves, more precipitation and rainfall, or to the hazards like more flooding or more drought, etc. But we are working also with the vulnerability, because people will feel differently the impact of climate change depending on the context in which they live. And what this map is showing is an aggregated indicator of vulnerability. Working Group 2 estimates that more than 3 billion people are living currently in contexts that are highly vulnerable to climate change. And you find them, of course, in Southeast Asia, in Africa, in Central and Latin America. And of course, it does not mean that Europe is not vulnerable to climate change. Europe is vulnerable, but it is less than other countries. And especially in Europe, you have 2 groups which are highlighted, which are very, let's say, vulnerable to climate change. These are the old people, because basically they are very vulnerable to heat waves, and also traditional people, indigenous people, like people in the Arctic, who see their environment changing very rapidly, and basically this threatens their whole future. But of course, we acknowledge that the most vulnerable people are in Africa and Asia and Latin America. If you go to Africa, you can see that 2 groups are mentioned, and this is not limited to these groups. These are women who are highly, let's say, who are doing a lot of work which is not included in the economic descriptions, and also children, and also in relation to agriculture, etc. If you go to Middle East, these are displaced people, for example. If you go to Central America, these are small holders of coffee productions. So we see a lot of different groups which are vulnerable to climate change, and aggregated, we find this map. This map is in the technical summary, and it's not in the SPM. We can acknowledge that this type of indicator is difficult. We integrate many aspects, like access to a reliable health system, access to infrastructure, the social protection, etc. And you can, for example, discuss whether a particular criteria should have a large weight in the final indicator or not. So it's difficult to come up with a single map, and it's probably the reason why it's not in the summary for policymakers. Then we acknowledge in working group 2 that we are seeing increasingly the impacts of climate change. And this is one table which you find in the summary for policymakers this time. And what you see here is impacts in different regions on water scarcity and production, on health and well-being, on cities and settlement and infrastructure. There is another table on ecosystems. And you see that the minus represent where you have increasing adverse impacts, and plus minus means that there can be positive and negative impacts. In general, when you look at this table, you see that the impacts are generally negative. And so if we take the example of Europe, there is a strong impact which is very negative, which is the impact on health and on mental health specifically. So on mental health, because after extreme events, after heat waves, we know that people basically are depressed, and this affects their mental health. We know also that there is evidence that people are concerned about climate change, and this can affect their mental health too. But of course, there is also evidence from impact on health, in particular in relation with heat waves. So just the basic impact of heat waves on people, especially when you have cardiovascular problems, etc. We see also that some impacts are mixed, like, for example, water scarcity. So basically, this affects more the southern regions than the north. On agriculture, because today what we see is that there is a loss of production of agriculture in the south of Europe, and it's mainly because of drought. But there is also an increase of agriculture production in northern Europe. However, if we aggregate everything, we see that the losses in the south are more significant than the gain in the north. And beyond 1.5 degrees of global warming, the losses are everywhere. So you can see that this is an example in Europe. Another example is in the Mediterranean. You see that we have more losses, the minus are everywhere, and we have more confidence in some of the losses. Just an example, water scarcity. We know that regions like the Maghreb, Spain, Greece, and the Balkans are very much affected by water scarcity in relation to climate change. This was one of the key messages of the working group 1. We attribute drought to climate change in the Mediterranean region with medium confidence. And finally, if you go this time on a particular topic, like, for example, flood and storm-induced damages, you see that the colors are different depending on the regions. So, of course, sea level rise is affecting coastal area in a negative way because you have more frequently flooding, because erosion is exacerbated. But the confidence in this statement, and this is negative, of course, but the confidence in this statement varies depending on the region. And we can explain that actually. For example, in Europe, we have low confidence in this statement. It's because there is really one single site where we have very high confidence that sea level rise has affected risks. This is Venice in Italy, where we see that the aqua alta are followed sea level rise. However, we don't have so many other places, and for a good reason. It's because we have high defense standards. We have very much urbanized the coast, and so the signal from sea level rise is masked from these due to these activities. If we go to North America, they have completely different protection levels. And for example, in the eastern US, they see more and more frequent chronic flooding at high tide because they have very low protection levels, and this affects their the access to infrastructure, to ports, to roads, and this is causing economic losses. So they have high confidence in this statement. So this figure, of course, is very rich, and you could take just 1 hour just discussing it. I would be unable to do that, but I have taken some example here. Then if we go to future impacts, this is the future impacts on terrestrial biodiversity losses. And what this map is showing is just whether species which are currently located in a specific area would be able to cope with the future warming conditions and with the future, let's say, precipitation, warming, wet conditions. And you see that with a 1.5 degree of warming, there is already a lot of losses. It can reach more than 50% in some region of Egypt, in North Siberia, in Australia. But for 3 degrees of global warming, we see impacts which are larger than 50% in many regions of the world, including Europe. For example, in Europe, the impact on insects is absolutely, there is a figure in the chapter 13. It's very impressive to see this figure. Basically, insects that are currently living in Europe would have to move elsewhere to continue being adapted to their climate conditions. So here, this statement here, which you see on the map, is translated in what we call a burning umber. So this burning umber represents how much the risks is increasing with global warming. So what you can see on the ordinate are the global surface temperature change. So it's not the local temperature change, it's really global. And in many continental regions, the warming would be actually more than that. And so we are currently at 1.1 degree, and we have more than high confidence that high confidence that climate change has already affected species. For example, the marine biodiversity in the Mediterranean and the corals in tropical regions. And as the warming is going on, we will go progressively to high risks, so in red, and very high risks in purple. And for example, by 2 degrees of global warming, the previous 1.5 degree report made the point that we lose 99% of the current coral reef cover, so which is very strong. So you can see how this map is translated in a burning umber. And this burning umber, of course, they are a bit difficult to explain. There is a lot of information behind that. In the supplementary material, you can see the justification for each burning umber. And this is generally a text with many publications. So you need a lot of publication, you need a lot of time and a lot of coffee to come up with one single burning umber like this one. And when we try to aggregate all the risks from climate change, so there is a framework called the reason of concern, which is made here in this figure from the summary for policymaker. So what you can see on the left is the increase in global surface temperature and the observed and projected. And what you can see on the right are the burning umber for the 5 different reasons for concerns. And so these reasons for concerns are unique and threatened ecosystems, like coral ecosystems, something like this. The second one is about extreme weather events, so increased heat waves and the impacts for health of people, increased heat waves and the impact for ecosystems, increased precipitations. The third one is about the distribution of impacts, the fact that in some region you will feel very strongly the impact of climate change. For example, the small islands in the Caribbean region, they estimate that 100% of the endemic biodiversity within these islands is at risk of extinction due to climate change. The global aggregate impacts are the 4th reason of concern. And so this is when you are able to aggregate all the impact at the global scale, like for example, the economic impacts of sea level rise could be, for example, you can aggregate them in terms of expected monetary value, monetary losses by 2100, and at the end, it represents a huge amount of money. And so you may say that engineering companies have the capacity to adapt to climate change in a particular area, but when you aggregate it over the world, you wonder whether we will have the capacity to do this everywhere. And then there is a 5th reason of concern, which is the risks of large-scale singular events, like, for example, forest dieback. So forests basically dying due to climate change, like the Amazonian forest, and also something that Gael and you know very well, the potential for an Antarctic ice sheet collapse. And so these band number here, they are here for assuming low to no adaptation. So you can imagine that, for example, there is some potential to reduce these risks compared to this situation here. But when you reach the very high risk impact, so the purple, it means that we are reaching the adaptation limits. And just as an example, the coral reefs, which fall within RFC1, the report on the ocean and coastal ecosystem in the Working Group 2 report makes clear that there is a limited potential for adaptation if we exceed 1.5 to 2 degrees of global warming. So there are some ideas that have been put on the table, but they are not proven. And so we are really at risk of a massive, let's say, extinction of corals in many areas in the world. However, I would say that it's true that, for example, in Polynesia, if there is a residual coral reefs, they could be in French Polynesia, for example, due to several reasons. So one of the conclusions of Working Group 2 is that to avoid the mounting losses, urgent action is required to adapt to climate change. So there are two urgencies: cut greenhouse gas emissions in order to keep a number of adaptation options open, but also adapt to climate change. And this includes reducing biodiversity losses, allowing us to achieve the sustainable development goals. So I'm going to make a focus on Europe now. And so in Europe, like in other regions in the world, our current 1.1 degree of global warming has affected natural and human systems. And so, of course, we see mean and extreme temperature and precipitation which are rising. We see that mean and extreme sea levels are rising too. And this has resulted in losses and damage for people, just the health during extreme heat waves, for ecosystems, so for example, losses in the Mediterranean region of fishes, for food system, so the fishermen in the Mediterranean are affected, the agriculture in South Europe is affected too, for energy and water availability, so for example, energy with less water in the Mediterranean region, the hydroelectric power is actually affected, and public health and the economy. And this is very high confidence. So what you can see on here is a projected, let's say, projected increase of extreme heat, of extreme precipitation, and of drought for 1.1, 1.5, and 3 degrees of warming in Europe. So, but at the same time, we see that adaptation is progressing. Adaptation is progressing. This is shown in this map here, where you see the sea level scenario, which are integrated in any regulation in different European countries. So in France, for example, we have a 60 centimeter sea level rise scenario, which is considered for 2100. It's integrated in the coastal risk prevention plans. It is used to prevent further urbanization of low-lying areas. So it makes sense. Basically, we say this in the cross-chapter box on sea level rise of the report, that the first thing that could be considered to reduce future coastal risks would be to avoid aggravating the situation by limiting urbanization in low-lying coastal areas. But in other countries, you see that you have much higher sea level scenarios which are considered. For example, several meters of sea level rise in the Netherlands and in UK. But we have to consider that this is for a stress test of infrastructure, like the Thames Barrier estuary. So this is basically a what-if exercise. Our colleague in the Netherlands and in the UK of the European, of the environment agencies and other organizations are just thinking what they should do if sea level rise exceeds, for example, 3 meters. And for example, in the Thames water estuary, their conclusion is that they are able to protect London with this barrier up to 3 meters of sea level rise. Beyond 3 meters, they should have another barrier which is more seawall in order to make sure that water is not affecting dikes in other sections of the estuary. So we see that adaptation is progressing, but it is generally fragmented, small in scale, incremental, sector-specific, and designed to respond to current impacts or near-term risks. And it's more focused on planning rather than implementation. So what we mean with incremental is actually, let's say, adapting step by step to climate change without considering the whole picture and without changing, transforming, for example, cities so that they are adapted to climate change. So basically for sea level rise, you could say that without a strategy, a long-term strategy to cope with long-term committed sea level rise, adaptation will remain incremental. So you should consider what will happen with all this infrastructure which we have on the coast on the long term, and this includes, of course, industrial area, power plants, ports, but also our the landfills that we have in the coast. All this should be managed, and without considering this broad picture, adaptation will be incremental. If we look at the progress of national adaptation policy in Europe, this is this figure on the right, you see that the states are reporting progress in many areas. So they are preparing the ground for adaptation with regulations, with things like this. They are assessing the vulnerability to climate change. And this is more in Western Europe than in the East. They are identifying adaptation options, but again, this is more limited to a small number of countries. And there is some monitoring of and evaluation of adaptation activities. So for example, in France, in 2015, the national adaptation plan was evaluated by the Ministry of Environment. But what is really a matter of concern is that the implementation of adaptation option is lagging behind. And this is a self-reporting of the states. And you see, for example, that except Hungary, let's say Switzerland, Germany, and UK, most countries report that they have made smaller progress in this area than in other actions related to adaptation. And this is limited to national adaptation plans, and you don't learn anything about regional plans or local plans in this figure. And I would expect that, for example, if we had an assessment on adaptation plan at regional and local levels in France, we would report small progress on the monitoring and evaluation of adaptation activities. So what are key risks from climate change in Europe? What you see here is an event which happened in 2016. This event was actually a heavy rainfall event in June. It affected North France, and in particular my city, Orléans, where you see that the highway was flooded. It is a highway connecting Paris to the south of France. So you can imagine the economic impact of having this highway closed during 1 or 2 weeks. It also affected these buildings here. They were basically inhabitable because there were cavities that were reactivated. So basically, you could see a wall in just close to the houses, so that to be just evacuated. And this event is twice more likely now than in a pre-industrial climate, just due to the fact that we have 1 degree of global warming, and so more intense rainfalls. The key risks in Europe are increased mortality and morbidity of people due to an ecosystem, due to heat. There are heat and drought stress on crops, and especially in Southern Europe. Water scarcity, especially in Southern Europe too, and inland and coastal flooding. So inland flooding, it's about heavy rainfalls, and coastal flooding, it's about sea level rise, of course. And in addition, we have the cascading risks on the top of this, like for example, when you have more drafts, the risk of wildfire increase. And this map, I'm going to comment it just now. This map that you see is the current and projected heat stress for people in Europe by the mid of this century. And for now, this is the top left figure. So you see that in Europe, the risks of stress from heat for people varies depending on the region. And so it integrates not only the intensity and the length of heat waves, but also the health of the people, so their age, how much they are vulnerable actually to heat waves. And you can see that in the future, by the mid of this century, depending on the greenhouse gas emission scenario, we can have different future. And so for the high emission scenario, this is SSP 3, 8.5, the risks are increasing drastically in most of the European regions. It's a bit the same for the middle of the road scenario, the 4.5 actually. But for SSP 1/2.6, it's interesting because we see that we would be able to make better than now. And we would be able to make better than now because this scenario assumes a socio-economic pathway, which assumes that we will change our diets. So there will be less people suffering from being from cardiovascular disease, from overweight and things like this. And we would also probably support our health systems, meaning that we can improve the situation compared to now by making both adaptation and mitigation. So it's a very strong, I think, message that we can make better than now by a very strong action on both adaptation and mitigation. And here you see a key figure. I think I'm taking too much time, so I will go a bit quicker. But you see that, for example, at 1.5 degree of warming, we expect 30,000 annual deaths in Europe due to these heat waves. And this is compared to a single event in 2010 in East Europe, where there were 55,000 fatalities in Eastern Europe, and which was really an extreme event. I'm going to go through these. I'm going to talk about sea level rise. So this is a figure showing first the results from the working group 1. So you see this observation of sea level rise and the projections for different scenarios of global warming. So now we prefer probably the SSP 3 7.0 compared to the catastrophic scenario of SSP 5/8.5, because there are policies that are in place that reduce global warming, and we expect that they will be continued. But we also show the two scenarios that would be below or well below 2 degrees of global warming, SSP 1 2.6, sorry, and SSP 1 1.9. We cannot exclude this collapse of ice sheets, which results from which is shown in the dashed line below. And what we expect is now, if you go to the coast, you will hardly see any obvious impact of sea level rise. But we are starting to see them in some regions. These high tide chronic flooding events. So you see a picture here. This is from our colleague of NOAA, and this disturbed infrastructure. Increased flooding during storms. And this is, for example, shown here with the Cynthia event in France in 2010, where the houses here were flooded due to a rupture of the dunes. And if we look into this event, we see that some of the dikes were overflooded just by 20 centimeters of sea level at high tide. And you may say, okay, we have just 20 centimeters of sea level rise due to climate change since the beginning of the 20th century. And finally, some erosion events here which are unrelated to sea level rise. So in terms of timing, you could see that we are seeing more and more high-tech flooding events. Increased flooding during storm, we are about to observe more impacts. Increased salinization, we expect it to arise later. And this is the same for increased erosion and permanent flooding. However, we also see early responders. And for example, for increased erosion, these are areas which are very isolated from a morphodynamic point of view. So there are not so many sediments coming into the system. And so you see the impact of sea level rise because other processes don't mask the effect of sea level rise. So it's exactly the contrary of this situation here in Aquitaine, where you have a lot of sediments which are transported by waves. Sorry. And here you can see just an example of what could be high tide flooding events. So this is in Guyana. It's a colleague of mine who took this picture. It was during a swell event. So this area is flooded because there is some swell and the waves are overtopping the small dunes that you cannot really see here. And it affects actually the road. And it's not a catastrophic event, but in the end, this is damaging probably some of the houses, and it's also affecting the transport. And with increased event like this, everywhere you have a loss of productivities for sure. So these risks from sea level rise are likely to increase by 1 order of magnitude, mainly due to increased damages during storm events. So you can see the basic idea here. You have mean sea level rise, but during the storm, there is an additional level of water level, which comes from the effect of winds, the effect of waves, the effect of reduced atmospheric pressure. And for example, one event that was considered centennial recently will become a decadal event in 2050, even with relatively small greenhouse gas emission scenarios. This is shown in this map. And finally, on the long range, we see that sea level rise represents a threat for low-lying coastal zones, for the communities, for the infrastructure, and the cultural heritage. So this is a figure from the Mediterranean region. You can see the cultural heritage sites from UNESCO, which are at risk from sea level rise during the 21st century. And you can see these two burning numbers. One is about the coastal risks when we exceed 2 degrees of global warming. So this will be 20 centimeters of sea level rise. And the second one is the impacts, the committed impacts. So when we exceed 2 degrees of global warming, we know already that we will have maybe 2 or 3 meters of sea level rise later. And this will impact, of course, the cultural heritage and other aspects. So we can say that even in Europe, adaptation alone is not sufficient to limit risks, especially above 1.5 degrees. So you can see the burning number for all the key risks that I listed previously. So risk for human health, for marine ecosystem, for terrestrial ecosystems, for crop production, for water in South Europe and Western Central Europe, for river and pluvial flooding, for coastal flooding. Now, when we exceed a certain global warming, and the committed impacts. And if we limit climate change to 1.5 degrees, we have, of course, we are going to limit a lot the risks. Maybe not for the delayed risk for the cultural heritage, but this is one of the motivations to limit impacts to 1.5. We limit considerably the risks. And this is the same for the Mediterranean region. You can see the same burning numbers here, except that we have added wildfires because it's very significant for most of the Mediterranean region, except the southeast. And you can see that with 1.5 degree of global warming, we limit also the risks, but there are still residual risks for marine ecosystem because basically marine species are trapped in the Mediterranean. They cannot migrate to the north. They are also progressively replaced by species coming from the Red Sea through the Suez Canal, and there is an impact of fishing. So we expect the marine ecosystem in the Mediterranean to continue decline this endemic system, and this has an impact for fishermen. So what are solutions, opportunities, and limits to adaptation? So what can be our future? Because of course it can be a bit, well, this is not a very nice message, but there is a way actually to escape from this, from this situation. We could adapt to climate change, so reduce climate risks, reduce greenhouse gas emission to let more adaptation options open, protect biodiversity to curb biodiversity losses, and maybe beyond 2050 start to recover, and finally achieve the sustainable development goals like reducing poverty, better education, better health, etc. And this is what we call climate resilient development. We know that it's difficult to achieve this because past and current development choices have long-lasting consequences and can lead to losses. It's shown here with what we call an adaptation pathway. So adaptation pathways show which type of measure you can take over time with increased global warming levels. And this is here, for example, for flood protection. Typically now you have many areas with flood defenses, but at some point with high global warming levels, we know that this will be unsustainable because of sea level rise. And so we have to consider planned relocation. And this is certainly what is missing today in many adaptation policies. But we could also have ecosystem-based adaptation. which will have more limits. Maybe with 2 degrees of global warming levels, we will have less protection offered by mangroves, by coral reefs, etc. But which will have a better, let's say, but this could be included in our choices. But we know that this type of adaptation pathway is very useful to have a broad picture about how we will adapt in the future, how we could adapt in the future. The second point is that we know that adaptation takes a lot of time. And this is the example of Venice. We see that sea level rise in Venice has affected high tide events of the aqua alta the same consistently. So it's consistent what we see in terms of aqua alta and sea level rise. Part of this sea level rise is due to subsidence there, 1 millimeter per year, but the rest is climate change. And there has been a barrier which has been created to protect from these high tide events. So the barrier is closed when you have a high tide. It's operational since 2 years now. But basically, what is important to understand is that this barrier took 40 years to be implemented. And actually, people were starting to think about this in the 60s after a large aqua alta event. So you see the time scale needed to adapt to sea level rise. And also, we have to consider that with the 50 centimeters of sea level rise, the barrier will need to be closed 2 months per year. So not only during the extreme event, but really 2 months per year, which would completely disrupt ship traffic and lagoon water exchange, so affect lagoon ecosystems. So we see that the adaptation option is just one step in the process. We may need to consider something else. We will probably need to consider something else, and it should be during the second half of this century. We see also that many adaptation measures are available, but their feasibility and effectiveness varies. And there are 2 examples here. One is about planned relocation. So planned relocation is very efficient. If you remove this building, there is no risk. But of course, it is not well accepted by people. So the socio-cultural feasibility is just low. Another example is ecosystem-based adaptation. So you see here a site of the Coastal Conservation Agency in France. And they have basically removed the first rank of dikes because they are very costly to maintain. And basically, they don't need them. They just need to protect their neighbor. So they build another dike more inland, and they allow the water to enter here. And the system just becomes more natural. It gives more opportunity for ecosystems. You can see that, but the protection, the effectiveness is actually a bit lower. With a larger sea level rise, it will probably not be sufficient alone. And there are wider benefits of adaptation. So you can see examples here for more than 3 billion people in rural area. Adaptation means more improved road, more reliable energy, clean water, and food security. For cities, including Europe, adaptation means green buildings, green spaces, cleaner water, renewable energy, sustainable transport in cities. For inequalities, we have a lot of aspects in the report which concern the gender equality, the role of women, etc. And of course, the impact of adaptation for ecosystems are generally beneficial. And this is summarized in this table, which you see in the summary for policymakers here. You see that all the plus here represent co-benefits of different adaptation measures for different sustainable development goals. So from one, reduce biodiversity, to, for example, this biodiversity losses. There are some exceptions, and one of them is coastal defense and hardening in response to sea level rise, which has for impact to reduce actually the possibility for ecosystems to adapt to still be present on the intertidal zones. So we have to be careful that engineering or sediment-based adaptation is not made at the cost of ecosystem losses, which is generally the case presently. You could say that sustainable development goals is a concern for developing countries, but it is not actually. If you see in France, this is the status in France now. We have just achieved 2 sustainable development goals: no poverty and industry, innovation, and infrastructure. So you may wonder why we have not achieved zero hunger. It's not because of hunger in France, it's because of the impacts of our diet. So we eat meat. This has impacts in other regions than Europe. And this means that we compromise the possibility for other countries to achieve their own sustainable development goals. And you can see that in different aspects of this transboundary issue, for example, in responsible consumption. So basically, adaptation will be beneficial, of course, for developing countries, but it will be beneficial for developed countries too. I'm a bit long, so I'm going through there. I think I have 5 minutes left, something like this. Okay, thank you. So what are the barriers to adaptation? Because if you see this picture, you could say, okay, that seems fine, let's do that. But of course, we are not doing it, actually. We are not on the track. And the barriers to adaptation vary from region to regions. In Europe, the main aspects are limited resources, the lack of private sector and citizen engagement, insufficient mobilization of finance, the lack of political leadership, and the low sense of urgency. If you go to the US, for example, the first barrier to adaptation in their report is the misinformation on climate change, which prevents actually actors to adapt, because at the end, it makes a lot of confusion and they don't see the necessity to adapt to something that maybe is just a hoax, you know. And if you go to Australia and New Zealand, their first barrier to adaptation is the problems in the area of governance. They see a lot of different actors which take different types of measure, and some of them favor adaptation, others not. And in the end, it's a bit chaotic, and this is a barrier to adaptation from that point of view. If you go to the African chapter, the first, so there are a lot of problems which are listed, but basically the summary is that climate change is just one of their many concerns, and so basically it cannot be in the top priority since there are a lot of problems with the food security, health. And why? And in the report, we also question why the transition to transformational adaptation is limited. And we mentioned vested interest, so basically interest, private interests that are not compliant with this project. Economic lock-in, the institutional path dependencies, so basically you are locked in by decisions that have been taken decades ago, and the prevalent practices, the culture, the norm, and belief systems. Belief systems includes, for example, if you believe in growth, like in the 60s in France or something like this, it's not only a religion. But at the same time, a national government should be careful, because if you ask European countries, European citizens, who is responsible for tackling climate change, the first response is national governments. And then European region or business and industries, depending on the date where the survey was made. So just a point about financial constraints. We know that we need financing to finance adaptation. And today, we estimate, the UN Adaptation Gap Report estimates that there are 70 billion of US dollars invested in adaptation in developing countries. So this excludes developed countries. And in 2030, the needs would at least double, and even more larger in 2050. But the current global financial flows are generally insufficient, and most finance target emission reduction, which is excellent, but we need also some finance for adaptation. We also make the point that climate impacts can slow down economic growth. So in general, if you look at this report, you see that there is increasing sense of urgency, and the author of the summary for policymakers may say that starting today, every action, every decision matters. So basically, we could have followed, let's say, another pathway just after the Paris conference in 2015, but we have not. And we had the COVID crisis. We can say that in the future, even if we go now for a more sustainable climate resilient development, there will be new crises, and we have one, of course, now, which is the war in Ukraine. But these crises, if they are, if we use this crisis to delay action of climate change, this will have huge impacts, and huge impacts for corals, we lose corals, for ecosystem, for the health of people during heat waves, etc. And so finally, the conclusion of this report is that the science is clear. Any further delay in concerted global action will miss a brief and rapidly closing window to secure a livable future, but also that this report offers solutions to the world. So you see a lot of adaptation measures that are presented. In the report of the working group 3, you see a lot of possibilities to reduce greenhouse gas emission. So we can still limit considerably the risks from future climate change. And the question is, what are we going to do? This will be the report of the author of the 7th assessment report who will do that. Thank you for your attention.
Thanks again, Gonéri. I presume there are some questions, and we have time for that here or online. So I don't know if there is something in the chat. Apparently not, but here, Nicolas.
Yes, thank you very much, Gonéri. Very excellent presentation, but to summarize the paper. You mentioned the Guardian, and I never saw in the IPCC report the impact of wars into the vulnerability and impacts on the person. Is it something included, or do you have assessment already?
It has been discussed a lot, actually, because you know, there are some literature suggesting that the war in Syria was driven by climate-induced reduced water availability. But the assessment that we have is that the evidence for this is weak, actually. Wars and conflict are driven by many different factors, and climate is just one of them. And it's really, you can have examples of conflicts that are actually resolved despite a climate driver. And for example, water management in the Middle East, for example. So finally,